Hello participants from all around the world, and welcome to today's webinar, which is on the topic of simplifying rational expressions. We had a very good turnout for today's morning session, and this is the afternoon session to accommodate for participants in different time zones. So before we get started, I would like to thank everyone for emailing me with their questions, feedback, and requests for new and interesting STEM webinar topics. And if any of you today have any questions, feedback, or requests from today's webinar, please feel free to email me. And in addition, for this particular webinar, it would be helpful to have some background knowledge of factoring polynomials, as we'll be building on our skills and the concepts of those in today's webinar. But if you do not, no worries, as I will briefly be going over that. If you would like to learn more about that after this webinar, I have actually done a webinar on factoring polynomials, which there is a recording of posted on my website. So with this, let's get started with today's webinar. All right, so the first question, which we'll be going over today, is going to be y squared minus 6y minus 7 divided by y squared minus 10y plus 21. And essentially, as the topic states, we are actually going to be simplifying these rational expressions. As you can see, we actually have a quadratic expression on both the numerator and denominator of this fraction. So essentially what we're going to do is we're just going to simplify this down further so we can actually get to canceling out common terms in both the numerator and denominator. So in order to do this, first we have to actually factor these polynomials. And to factor, we have to think of two numbers. So taking a look at the numerator, we need to think of two numbers that when multiplied will give us -7, but when added will give us -6. And those two numbers would be -7 and +1, which satisfy this criteria. So -7 and +1. And for the denominator, we have y squared minus 10y plus 21. So therefore, we have to see two numbers that when multiplied will give you 21, but when added would give you -10. And the two numbers which would satisfy this criteria would be -7 and -3. So essentially now, using these two numbers, which we have established, we're going to use these and write these as coefficients of our variable here. In this case, our variable is y, so we're going to be writing these numbers as coefficients of y in order to create the sum of the middle term for each polynomial in both the numerator and denominator. So what I mean by this is first taking, for example, the numerator, the polynomial on the numerator, which is y squared minus 6y minus 7. We're just going to essentially write our two numbers, which you've established, which is -7 and 1, as coefficients of y, and create a sum of the middle term, which is -6y. So I'm just going to write this out. So we have now y squared, and we have -7 and 1 as our two numbers. So what I'm going to do is I'm going to write plus y minus 7y minus 7 here. And all I've essentially done is written our two numbers, which we have as -7 and 1, as coefficients of y. And I've just essentially written that as the sum of the middle term here. And as you can see, y minus 7y will give you -6y, which is what we have for our middle term for our numerator. So now we're just going to be conducting the same thing in the denominator. So in the denominator, we have y squared minus 10y plus 21. And what I'm going to do here is just taking this y squared here And we have established our two numbers as -7 and -3. And essentially, I'm just going to do the exact same thing and write these two numbers as coefficients of y in order to create -10y as the sum for our middle term. So now I'm just going to be writing -7y minus 3y, and then just writing plus 21, which is what we have at the end over here. And now what we're going to do is we're just going to actually factor these further. So in order to actually factor these further, as you can see in both the numerator as well as the denominator, what we have is actually 4 terms in each. So in order to factor this, what we actually have to do is take a look at the 4 terms in the numerator, and we're actually going to be splitting these up into 2 separate groups. So y squared plus y is one group, and -7y minus 7 is going to be another group here. And same thing for the denominator. As you can see, we have 4 separate terms. So what we are going to do is we're just going to split it into 2 separate groups so we can easily factor. So now what we're going to do is we're going to pay attention to our numerator first. As you can see, I have created 2 separate groups with 2 terms in each group. So our first group in our numerator would be y squared plus y. So what we have to do is just looking at that group with 2 terms, we're going to factor out the common term. So in y squared plus y, the common term is y. So I'm just going to factor out y here. And if you do factor out y, as you can see, what will happen is factoring out y, you would get y plus 1 in the brackets. And if you actually multiply this out, you get y squared plus y, which is what we originally had here. And now what we're going to be doing is paying attention to this group over here, which is -7y minus 7, and doing the exact same thing and just essentially taking out our common term, just factoring that out. Common term here would be -7. So it's going to factor this out. So -7 times y plus 1. And as you can see, if you actually distribute this, if you do -7 times y plus 1 and you distribute it, you would get -7y minus 7, which is what we have here in this group on our numerator. And now carrying out the exact same process for our denominator. So as you can see, we have 4 terms in the denominator, which I've split into 2 separate groups. And first group would be y squared minus 7y. And factoring out the common there, the common would be y. So we're just going to be factoring that out. And now in the brackets, we have y minus 7. And over here, as you can see, if you factor out the common over here, we would actually have factoring out our common, which would be essentially minus 3y plus 21, which is what we have here. So we're going to be factoring that out. And when we factor it out, we're actually going to factor out common, which is -3. So factoring out -3 as our common, as you can see, when you factor that out in the brackets, what we would have is -3 times y minus 7, which is what we get if you factor out -3, which is the common. And now, finally, we are just going to pay attention to what we have so far. And in the numerator, we have this over here. And as you can see, we have the bracket of y plus 1 repeating twice here. So that's the common bracket. So we're just going to be writing that common bracket of y plus 1, which is that bracket which repeats twice. And then in another bracket, we're just going to be writing y minus 7. Because as you can see, we have a y multiplying this y plus 1 bracket over here, and a -7 multiplying this y plus 1 bracket over here. So essentially what we're going to do is we're essentially just going to write those y minus 7, which are the multipliers for those common brackets. And now, finally, just dividing that and looking at the denominator, what we now have would be y times y minus 7 minus 3 times y minus 7. And as you can see here, we yet again have a common bracket, which is y minus 7. And that is multiplied by the terms y and -3. So as you can see, what I'm going to write here is y minus 3 because we have y over here, which is multiplied by y minus 7, the common bracket, and a negative 3 here, which is multiplied by y minus 7, which yet again is a common bracket. And finally, we're going to be actually getting to the actual simplification of our rationals here. And we're going to be simplifying common terms in both the numerator and the denominator. So essentially, as you can see, we have a y minus 7 in the numerator and a y minus 7 in the denominator. So I'm going to be canceling out y minus 7 and y minus 7 in both the numerator and denominator. And this just essentially leaves us with y plus 1 divided by y minus 3. And this is exactly what our answer would be when we actually simplify this rational expression. So we're actually done with the simplification of the rational expressions for this problem. However, we have one last thing which we need to do, and this is essentially find the restrictions of this. So restrictions are values which make the denominator equal to 0, because as I'm sure many of you do know, if the denominator is 0 in a fraction, it is considered undefined. So we actually have to find values which would actually make the denominator 0. If you substituted those values into y, the denominator would actually be 0. So in order to figure out what our restrictions are, what we have to do is we have to actually equate our denominator to 0. So what we have here is, now we have y minus 3 in our denominator. So what I'm going to do is just say y minus 3 is equal to 0. And therefore, if y minus 3 is equal to 0, if you added 3 on both sides, we would get y is equal to 3. And if you actually plug this value of y equals to 3 into this y over here in the denominator, you would actually see that this becomes 3 minus 3, and that would be 0, and therefore the denominator would be 0, which make this fraction undefined. So now that we know that y is equal to 3 when we actually equate the denominator to 0, since we know that if we substituted that value into the denominator and that would make the denominator 0, we can go ahead and conclude that therefore y is not equal to 3. And therefore, this is our last step and our last conclusion we actually need to arrive at for these kinds of problems, just stating the restrictions here. And just to quickly go over what this actually means in real life, if you had the graph of a rational expression, so I'm just drawing an x and y axis over here, and say you had the graph of this rational expression, the graph would look somewhat like this, with these two L-shaped curves on the opposite quadrants. And essentially, what this means is these two L-shaped graphs here for this graph of the rational expression would actually never ever touch a vertical asymptote of x is equal to 3. So take this red line, and we're going to say this is when x is equal to 3. So as you can see, at this x equals to 3 line, these two L-shaped lines over here, which represent the graph of the rational expression, would never ever touch this x is equal to 3 vertical line over here. So no matter what, it will never ever touch those lines of x is equal to 3, this vertical line. And this is what you would call a vertical asymptote. So it's essentially just a line on the graph, in this case, vertical asymptote, so it would be a vertical line on the graph, which would actually never ever be touched by our graph over here. And that's exactly what it would mean in real life application. So now that we've established this, we can move on to actually doing another problem. So over here, we're going to be doing a second question, and this would be a squared plus 5a minus 24 divided by a squared plus 6a plus 8. And this is going to actually be multiplied by a squared plus 4a plus 4 and that's going to be divided by a squared minus 3a. So essentially what we're going to do now is, as you can see, this is actually a very similar looking problem as what we did just previously before this, but instead of there just being one fraction with quadratic expressions on both the numerator and denominator, what we actually have are two separate rational expressions multiplied together. So we're actually going to be conducting our simplification the exact same way, where we're going to be factoring our polynomials and then just canceling out common terms in both the numerator and denominator. So essentially, what we're going to be doing now is the exact same thing in establishing two numbers. Yet again, carrying out a process of factoring polynomials. So for this over here, our first polynomial in our fraction to the left on the numerator, we actually know that we have to get two numbers that when multiplied would give you negative 24, but when added would give you positive 5. And these two numbers are none other than 8 and negative 3. So these two numbers when multiplied would give you negative 24, but when added would give you positive 5. And same thing over here. What we're going to actually do is we're just going to essentially carry out our exact same process over here. So in the denominator, we know that we have to get two numbers that when multiplied give you positive 8, but when added give you 6. So those two numbers would be 4 and 2, as when you multiply those, that would give you 8. But if you add those, it would give you 6. And now looking at this polynomial in the numerator of our fraction on the right, we know that we have to establish two numbers that when multiplied would give you positive 4, but when added would also give you positive 4. And those two numbers are 2 and 2, because when you multiply 2 and 2, it gives you 4, but when you also add 2 and 2, also gives you 4. And finally, as you can see in this denominator over here, this a squared minus 3a, we actually do not need to find two numbers as there is no constant term at the end. So it's actually not a polynomial in the form of ax squared plus bx plus c. So we can just simply just factor out our common term in our next step, which would be a. So now what we have to do is we have to actually write our numbers which we've established as coefficients of our variable a in this case, and write them as the sum of the middle term, exactly as we did in our very first question. So now what we're going to do is we're just going to be writing this a squared, and now we're just going to be writing plus aa minus 3a. And then writing minus 24, which is what we have left. So essentially, I've just written this 8 and minus 3 as coefficients of a and just split them. So I could actually form sum of 5a, which is our middle term. And we are going to divide that by a squared plus 4a plus 2a. And that's going to be added with 8. And as you can see, we once again made our two numbers as coefficients of a, which is our variable term. And we're going to be doing the exact same thing here as well, just writing our squared term here, and then just splitting our middle term into our two separate terms, which actually have the coefficients of the two numbers we found, which are 2 and 2. So we're going to write plus 2a, once again, creating the sum for our middle term, which is 4a. And then finally, just writing that constant at the end. And finally, as you can see here, we have a squared minus 3a. So what we're going to do is we're going to be factoring out the common there. The common there is a, that's the common term. So factoring out a, we have a times a minus 3, which is what you would get if you actually factored. So now carrying out our exact same process of, now as you can see, we have 4 terms over here. So we're just going to be splitting into 2 separate groups, 2 terms in each group. Same thing over here and same thing over here. So essentially wherever you can actually split it. over here in this denominator, it is not necessary as we've already factored. So now what we're going to do is taking a look at each group in both numerators and denominators of the fractions. We're just essentially going to be factoring out the common in both. So over here, taking a look at our first group for our fraction on the left, on the numerator, we have a squared plus 8a. And essentially the common there would actually be a. So we're going to be factoring a out. So a times a plus 8, which is what we get if we factor that out. And then taking a look at our second group, which would be negative 3a minus 24, we're just going to be factoring out the common here as well. And the common here would actually be negative 3. So factoring out the common of negative 3 in the brackets, we would actually get negative 3 times a, and that is also going to be plus 8. And as you can see, if you would actually distribute this, it would give you negative 3a minus 24. And we're going to be doing the exact same thing yet again. First, taking a look at this group, which we have as a squared plus 4a, factoring out common, which is a. So factor out a, we have a times a plus 4. And now finally, we have our last group in the denominator. We have 2a plus 8. And the common here would actually be positive 2. So factoring out positive 2, we have times a plus 4. And now what we're going to do is we're going to do the exact same thing for the numerator for the fraction on the right. And essentially just going to be carrying out the exact same factoring process as well. So taking a look at our first group, we have a squared plus 2a. Factoring out our common is a. So factoring out a, we actually have a times a plus 2. And finally, our very last group on our numerator, we have 2a plus 4. The common there would actually be 2. So when we times 2, add 2, and then we'd actually be multiplying that with a plus 2. And now, finally, what we have here is our a times a minus 3, so we're just going to write that as is. And finally, what we're going to do is conduct another step, which is essentially just writing these into simpler form. So as you can see over here, if you take a look at this numerator over here, where I've marked this red arrow, we have a common bracket of a plus 8. So just writing that common bracket out. And we have to multiply that with what we have multiplied with our common bracket of a plus 8. So we have a minus 3 multiplied with our a plus 8, because we have a multiplied with this a plus 8 bracket and minus 3 multiplied with this a plus a bracket. And what we're going to do now is just going to be carrying out even more simplification in the denominator of this by essentially just taking our common bracket once again, which is a plus 4 over here, and just multiplying that with our terms, which are multiplied with our common brackets of a plus 4. So first one would be a, and then it would be positive 2. So now what we're going to do is we're going to do the exact same thing for the numerator on our fraction for the right side. And as you can see, we yet again have a common bracket of a plus 2. So we're just going to write that common bracket out. And next, we're just going to be writing another bracket, multiplying that by another bracket, which will contain our terms which are multiplying with the common brackets of a plus 2. So it would be a plus 2 yet again, because we do have an a multiplying with this a plus 2 and a positive 2 multiplying with this a plus 2. So we're just going to be writing those out. And that is just all divided by a times a minus 3. And now this is exactly where we can actually conduct our simplification of rational expressions yet again. And we're just going to cancel out common terms in both the numerator and denominator. So as you can see, we have an a minus 3 over here and an a minus 3 over here. So I'm going to cancel those out. We have an a plus 2 over here and an a plus 2 over here. So I'm going to cancel those out. And finally, we actually have nothing else we could cancel out. So I'm just going to write what we have left, which is a plus 8 times a plus 2, and that would be divided by a plus 4 times a, which is what we have left. And now we are done essentially with the simplification of this rational expression. And as you know from our previous problem, we have one more final step to do, which is to figure out our restrictions. So figuring out our restrictions, we know that restrictions are values which would make the denominator 0, and we know that the denominator is 0, it would be undefined. So we're trying to find values which would actually make the denominator 0. In order to do this, what we have to do is now we have to equate each bracket, if you will, in the denominator to 0. So what we have here is a plus 4, and that's multiplied by a. So what I'm going to do is I'm actually going to say that a plus 4 equals 0, and a, which is the term which is multiplying with that a plus 4, is equal to 0. So I'm just going to basically equate each term which is being multiplied with each other in the denominator to 0. So now we just simply have a is equal to 0, but as you can see here, we have a plus 4 is equal to 0, and if you subtracted 4 on both sides, you would get a is equal to negative 4. So finally, we have a is equal to negative 4. So essentially, these are values which we actually get. So now, as you can see, we have a is equal to negative 4 and a is equal to 0, and these are the restrictions. These are actually the values that if you substituted these into a, it would make the denominator 0. So therefore, we can go ahead and conclude that a is not equal to 0 and negative 4. So these are values which a is not equal to. And therefore, we just go ahead and conclude that. And this actually brings an end to this question. And this would be your final answer. So we're almost done here. But before we leave, I'm going to be actually giving you one more problem, which you can try on your own for practice. And I'll just do the first step with you guys so you guys are more familiar with this. So the next question, which we're actually going to be doing, is 3 divided by a minus 4 plus a divided by 2a plus 7. So as you can see, this is kind of a similar idea to our previous problems, except instead of there just being one fraction or multiplication between fractions, there's actually addition between the two fractions. So as you would when you regularly would add fractions up, what we have to do is find a common denominator, and that's the only way you can actually add the fractions up. So if we find a common denominator, or LCD is what you would call it, so we need to find the LCD. So we know the lowest common denominator is actually going to be a minus 4 times 2a plus 7, as when you actually multiply these, this will give us the lowest common denominator we can work with, and henceforth the lowest denominator which we could possibly make these two fractions at in order to add them. So now what we're going to do is, now that we've established our lowest common denominator, you would now need to exactly how you would if you just added fractions without variables, just regular fractions, you would have to multiply both the numerator and denominator of both fractions by a certain amount in order to actually make the denominators common or the same. So for this, 3 divided by a minus 4 fraction, what we have is a minus 4 in the denominator, but we need a minus 4 times 2a plus 7 in the denominator. So if we multiplied both the numerator and denominator by 2a plus 7, we'd be able to achieve a common denominator. And that's exactly what I'm just going to be doing right now. And now, exact same thing for this fraction over here. What we're going to do is taking this a divided by 2a plus 7 fraction, we know that the common denominator, yet again, is a minus 4 times 2a plus 7. So in order to make the denominators the same, we would have to multiply both the numerator and denominator by a minus 4. So now taking a look at this, we have a times a minus 4, and that is going to be divided by a minus 4 times 2a plus 7. So I've just simply multiplied both the numerator and denominator by a minus 4 for this fraction. And now we have to carry out this step. And as you know, when we have the denominators as common, we can actually just go ahead and just simply add them. So now we can therefore say that if we had 3 times 2a plus 7 plus a times a minus 4, and that would be divided by a minus 4 times 2a plus 7, because that is a common denominator. And now I'm just going to leave the rest up to you guys to actually solve on your own. All you would essentially do now is, as you can see, the brackets are not common, so we have to actually just expand the brackets out and then create a factoring polynomials question, which we can then factor and see if there are any terms we can actually cancel out on the numerator and the denominator. So therefore, I'm just going to leave you guys with this, but before I do, I'm just going to just simply provide you with the solution to this question. And the solution is going to be y squared, a squared, plus 2a plus 21 divided by a minus 4 times 2a plus 7. So essentially, I'll actually write this out once again for you guys. So essentially what we have is a squared plus 2a plus 21 divided by a minus 4 times 2a plus 7. And finally, this is our solution, and I'm just going to provide you with the restrictions as well. So therefore, the restrictions are going to be a is not equal to 4 and negative 7 over 2. And now just using these solutions and the restrictions, you can actually try this one on your own. So you can actually see if your solution matches the solution I provided you with. And with this, we are actually going to come to an end of today's session. So before I end today's session, I would just like to thank everyone so much for attending today's webinar. I hope everyone enjoyed, and if you had any questions, feel free to email me once again. So in addition, my next webinar will be held next week on the topic of coding, and it'll be essentially on how to code and design your own apps. So please look forward to that, and if you would like to actually register for that, information for that will be posted on my website, which is displayed on the screen you're viewing right now, and is also going to be written in the chat. And if you are interested, please check out our website once again on how you would register for that. So keep in mind that this session is actually going to be recorded too. So if you would like to go back and actually view this recording, you may do so. And once again, that recording will be on our website. And with this, we have come to an end of today's session, and I'd like to once again thank all participants from around the world for actually attending today's session. I hope you enjoyed and was able to take away something new and useful from today. Thank you and have a great weekend.